Welcome guys to section 1.4 talking about quadratics. Okay, so quadratics are equations that can be written in the ax squared plus bx plus c form, and this is often referred to as the standard form of a quadratic equation, right? So here we've got some examples of quadratics, and the key thing to note about quadratics is that they always have this power of 2 as its highest degree, and that's going to be what defines it as being a quadratic. Okay, so as we get into how we solve quadratics, we'll look at the zero factor property, which is essentially when you factor down an expression, each factor can be solved for its own zero. And so they mention that in the green box. They say, hey, a and b are complex numbers where ab equals 0. And if a times b equals 0, either a or b, or maybe both, are equal to 0. Okay. And so what we're going to do is we are going to factor down the expression that they give us, and we're going to solve it to figure out what would make it equal to 0. All right. Let's take a look at our first example here. So in order to solve this example, we need to lead by not trying to break down the right-hand side, but first actually moving this 3 back to the other side. So we'll have 6x squared plus 7x minus 3 equals to 0. And we always need to get the expression to equal 0 in order to be able to solve it. Okay, so now we're going to take this quadratic and factor it. Remember, if we use grouping, we can multiply 6 times negative 3 to get negative 18, and break it down to get numbers that will add up to 7. So I'm going to use positive 9 and negative 2. So split this up. We've got 6x squared plus 9x minus 2x and minus 3. So now what we're going to do is we're going to take this and we're going to group each of these terms together. So grab our first two terms and our last two terms, and we can factor it. So from here, we'll take out 3x. And when we do that, we're going to have 2x plus 3. From our second group, we'll take out a negative 1, and we'll have 2x plus 3. So again, remember, each of the remaining parentheses should be matching. When we put it together, we should have 3x minus 1 times 2x plus 3 is equal to 0. Okay, so once we've got these two factors, we can now finish solving to get our answer. So in order to get the solutions here, we'll just take each factor and go ahead and set it equal to 0 and solve it. So 3x minus 1 equals to 0, and 2x plus 3 equals to 0. We can do add 1, divide by 3 to get x equals 1/3, and subtract 3 and divide by 2 to get x equals negative 3 over 2. And we find these two solutions to our quadratic here. So this process of factoring down the quadratic and then finding the solutions of each individual factor is an application of the zero factor property, right? It means that if you want this product of 3x minus 1 and 2x plus 3 to equal 0, one of those factors must at least equal 0. Now, another property we can use to solve a quadratic is the square root property. And essentially, what we can do is, if you can get it to be in the form of x squared equals k, where k is, of course, some constant number, you can take the square root of both sides, and you could solve it and find that x equals either square root of k or the negative square root of k. Okay, and this is kind of where that plus minus often kicks in that we're used to seeing when we take square roots, that hey, it's going to be plus or minus a number, not just the plain number, right? So essentially, some of these are pretty simple, like x squared equals to 17. We're just going to take the square root of both sides. And when we do, we would get that x equals plus or minus the square root of 17, okay? So remember, whenever we take a square root, we do need to acknowledge the fact that it is both a positive or a negative solution. And so we can write plus minus. So some people, you will see it as a set, which is written as root k and negative root k. So we might have written x equals root 17 and negative root 17, but this is an abbreviation of that where you see plus minus in the front. Okay. Let's do the same thing on the next one. So here I've got x squared equals negative 25. Same idea, let's take the square root. The only difference this time is since I'm square rooting a negative, you'll remember from the complex numbers unit, we would get that this is I root 25, and with our plus minus, which finally would simplify to just 5i. So plus or minus 5i, okay? And the I comes, of course, because the number we square rooted was a negative, okay? Last one is a little more interesting. You'll see that it's not just x squared equals 12. We have x minus 4 is equal to 12. We're going to lead out with the same expression. We're going to say x minus 4 squared equals 12. And then we're going to do the same step of taking that square root of both sides. So when I do this, I've got x minus 4 is equal to plus or minus the square root of 12. And we can go ahead and also simplify the square root of 12. Hopefully you remember this. Square root of 12 is going to be 2 square root of 3. Okay, that's 12 breaks down into 2 times 2 times 3. Okay, and we pull the 2 out. So we've got that plus or minus is equal to x minus 4. And let's move the 4 back to the other side so that we can solve for x properly. Okay, just be careful. We can't combine these because these are not like terms. 2 times root 3 is doing its own thing. It cannot be combined with that 4. So I've got x equals 4 plus or minus 2 root 3. And you could also write this expression separately as 4 plus 2 root 3 and 4 minus 2 root 3. Okay, so expression in red here and the two that I wrote in black are the same thing. You could interchange them, but in black you need to write both. Okay, let's take a look at another way to solve a quadratic. So far you've seen us use factoring, then we took the square root, and now we're going to use a process called completing the square. Okay, now this might be the most involved of the processes, and so it takes a little bit of finesse and being careful with our algebra to make sure that we get it right. Okay, the green box has kind of summarized how we're going to do this. So if you want to follow along with the steps that they've given in the green box as we solve these examples. Okay, so in our first example, 1.43, we're going to use completing the square, but we're going to get to skip step 1 because there's no a value, okay? So step 1 was to divide by whatever that a value is. We're going to skip that. We're going to rewrite this now so that the constant term is on the opposite side, okay? So we're going to move our constant, which in this case is 14. We're going to add the 14 and move it to the other side. So now I've got this x squared minus 4x equals to 14. And I've left this blank space here for a reason. We are going to actually add a number into this blank to make this equation into a perfect square. So what they tell you is you're going to square half the coefficient of x and add it to each side of the equation, okay? So in this case, our equation coefficient is negative 4. It's the b value if you're thinking ax squared plus bx plus c. So what we do is we take negative 4, divide it by 2, and then we square it. And you should get that this is actually going to equal 4 again. So I'm going to add 4 to both sides. Okay, so that was step 3. Add 4 to both sides. Now, this left-hand side is a perfect square trinomial, so you can take a moment to factor it if you'd like. And if you factor it, you should get x minus 2 squared is equal to, now these two together make 18. So by adding this 4 here, you've created a perfect square binomial, which then factors down into this. And you'll notice that x minus 2, negative 4 divided by 2 is that same minus 2 that you see there. Okay. Now we're ready to finish solving this. And now it looks like the square root problem all over again. Let's take the square root of both sides. And we're going to end up over here with x minus 2 equals plus or minus square root of 18. Okay. And let's go ahead and move this 2 back to the other side. So I've got x equals 2 plus or minus root 18. And let's go ahead and clean this up. Root 18 does simplify, and it becomes 3 root 2. So we've got that as our final solution. X equals 2 plus or minus 3 root 2. Okay, so you can see the steps in the green box and how we followed them. First, we moved this constant term, the 14, over to the opposite side. Then we went ahead and added this 4 to both sides, right? Remember, by adding to both sides, you keep it balanced. That makes a perfect square binomial. Take the square root, and you'll be able to finish solving this, okay? Now, the next example is actually very similar. It's just there's an a value. I have a 9 in the front here. So we just lead out by dividing everything by 9. Let's divide both sides by 9, and then we'll continue to solve this the same way. Okay, so I've got x squared minus 4 over 3x plus 1 is equal to 0. Okay, and from here, it's kind of the same process we used on the previous problem. So we're going to start by moving the 1 over. X squared minus 4 over 3x plus a blank is equal to negative 1. Filling in the blank, we take the middle term. This coefficient is the one I'm going to care about. We're going to divide it by 2, and then we're going to square it, okay? So negative 4 over 3 divided by 2, and then we're going to square this whole thing. Now you should end up getting 4 over 9, so we'll add that to both sides. So here's 4 over 9 and plus 4 over 9. Okay, so of course my left-hand side is a perfect square now, this piece right here. And that's going to break down into x minus 2/3 squared. Okay, so that is if you factor this. Using the perfect squares binomial formula will really speed up this process. Okay, so keep that in mind and try to make sure you have that memorized. Okay, and that is going to equal the right hand side simplified, which is just going to be negative 5 over 9. Now, to proceed from this point, guys, we're going to use the same square root method. The numbers are a little bit more complex this time, and we end up getting i's with some fractions and stuff, but still something that we can simplify in the exact same method. So let's take the square root of both sides, and we've got this. X minus 2 over 3 is equal to the square root of negative 5 over 9 plus or minus, okay? And I know this is going to simplify, but we'll wait until the end to do that. Let's go ahead and move this 2/3 to the opposite side by adding it. So here we've got x is equal to 2 over 3 plus or minus the square root of negative 5 over 9. Okay, let's simplify our radical portion. Okay, 2 over 3 plus or minus negative 5 under a root is going to bring out an I. We're going to have root 5, and the square root of 9 is just 3. Okay, now you may see it written slightly differently. You may see it with the I at the end of the fraction. You may see it up on the top of the fraction, but they both mean the same thing. Okay. Remember to keep your notation in standard form. Don't try to combine these two fractions together. Make sure that you are keeping them separate, otherwise you're not in standard form. Completing the square is probably the most algebraically intense method to use. However, it does open you up to solving things in a very exact manner and doesn't require a lot of simplification once you take the square root. Okay. The next method we talk about, the quadratic formula, is a little more brute force. Okay, so getting to the quadratic formula now. Now, this one's a pretty popular way to solve a quadratic, and it's one of the most powerful. It's a little bit brute force, but the best thing about it is it can solve pretty much any quadratic as long as it's written in standard form. Okay, so standard form again, ax squared plus bx plus c equal to 0, and then we will be able to solve it using this formula. So quadratic formula is given in the green box. And just remember that a, b, and c are reflective of the coefficients of the equation, right? So a is not going to have x squared, it's just going to be a number, okay? All right, so let's go ahead and take a look at our first example. First, get it equal to 0, right? X squared minus 4x plus 2 equals to 0. A is going to be 1, B is -4, C is going to be 2, okay? And that's just coming from each of the positions in my equation, A, B, and C. Now, we're going to go to the equation that they've given us, and we're just going to fill in the numbers as they're given. Negative B, so -4, plus or minus, square root, B squared, make sure you're careful with your sign here, -4 squared, minus 4 times 1 times 2, and that's all going to be over 2a, so 2 times 1. If we start to simplify this, the easiest place to kind of start is that first number. It just becomes a positive 4, plus or minus, let's see if we can simplify the radical a little bit, square root of 16 minus 8 over 2 on the bottom. And let's go ahead and finish out simplifying our radical. 16 minus 8 is just going to be 8, which we can then break down into 2 root 2. So now here we are, 4 plus or minus 2 root 2, all divided by 2. And yes, this all simplifies. Each of these can be divided by 2, so we can simplify this down. And we end up with this, 2 plus or minus square root of 2 as my solutions for this quadratic, right? So you can see the computation can be a little bit tedious, but overall, once you plug in the numbers, you can just simplify each piece down and solve it, okay? Remember, if you get an imaginary number, make sure you write it in that standard form. Let's try another one using the quadratic formula again. Once again, we need to get equal to 0. So let's move these two back to the other side. 2x squared minus x plus 4 is equal to 0. Take a second, identify your a, b, and c, and you should get 2, -1, and b for those numbers. And then let's go ahead and set it up. So go ahead, pause, set it up if you want, and check against what I have. Okay, so now if you fill in your quadratic formula, it'll look something like this. -1 plus or minus the square root of -1 squared minus 4 times 2 times 4, and that whole piece over 2 times 2. Let's go ahead and simplify this down. Again, negatives cancel out here. So we've got 1. So now let's handle the inside of the root. We should end up with square root of 1 minus 32, and that should become plus or minus square root of -31, okay? All over 4, okay? And let's go ahead and pull the I out from this, right? Because we have a negative in the root. Let's make it an I. And of course, I'm not going to leave it like this. Let's make it into standard form. 1 over 4 plus or minus I root 31 over 4. Okay. And again, you might see it also, instead of this, written as root 31 over 4i. And that is the same thing. Okay. Both of these are the exact same value. They're just written slightly differently. Okay. Last thing about quadratics, let's see how we can solve for a quadratic variable from different equations, okay? And we're going to use the same methods we saw when we solved these quadratics earlier. So example A here, we're going to solve for D, and we're going to use the square root method. So A equals pi diameter squared over 4. This is the area of a circle based on the diameter, right? Many of you are used to the radius formula, but this is the same thing from the diameter. Let's lead by multiplying 4 to each side. So 4a is equal to pi diameter squared. Divide each side by pi. And we've got this now. 4a over pi is equal to the diameter squared. And we can finally take the square root of both sides. And remember, when you take the square root, we'll use a plus or minus symbol. Okay. So my final statement looks something like this. D, the diameter, is equal to plus or minus the square root of 4a divided by pi. Okay. And now I'll take a moment to mention this. We did put plus or minus on here, even though we know a diameter is a length and it's got to be positive, right? It can't be a negative number. But still, for now, we just mentioned it. But it is something to keep in mind. Depending on the situation that you're in, you may be able to discard the plus minus just by saying, hey, we can't have a negative length or a negative time in this problem. And let's take a look at example B. Example B has actually a quadratic and linear term of t. And so in order to solve this, we're going to need the quadratic formula because we don't have numbers, so we can't really factor, but we can still solve for t using the quadratic formula. Okay, so let's move k back to the other side. R t squared minus st minus k equals to 0. Okay, and what we're going to do is let's identify what our a, b, and c are in this case. So a is r, b is negative s, and k is my c value, that negative k. Okay, and so basically we're going to fill in the quadratic formula using r, negative s, and negative k for a, b, and c, and that should kind of get us to a solution. So I'm going to go ahead and set up the quadratic formula. You can do so as well, and then unpause and see if your setup matches mine. And now based on this setup, we can kind of clean things up a little bit. So the double negatives cancel. We've got s plus or minus the square root. Negative s squared is just s squared minus 4, and minus k will make this a plus 4rk, all divided by 2r. And that, guys, is actually equal to the t, two different values, one plus and one minus, s plus that value and s minus that value. So that is solving for t using the quadratic formula. Even though we don't have any numbers, we were able to rewrite the expression in a way where t is isolated. So in these last two examples you saw, we can apply some of the techniques that we got for solving quadratics to solving them even when we have no numbers. We can still use these same techniques, right? Like quadratic formula, like factoring even maybe, or even completing the square. I hope you guys find these examples helpful. Good luck studying and with your homework.